Hello, we are remote. We are bachelor's CSAI students at Tilburg University. We're here at Mind Labs. I am Spatika and I will be the person presenting it. Right next to me, we have Kasia and Quila, who are also my team members. And then we also have Paula. So imagine the worst situation that happened to people, which causes them issues in communication. It could range anywhere from physical accidents, mental accidents, just the lack of communication skills and more. We wanted to try to investigate whether BCI could be used to help recognize and communicate emotions through EEG signals. And so this was the general plan we came up with. An individual will receive a stimuli, either through another individual, a recalled memory, or a visual aid of any kind. The EEG data using the unicorn hybrid black will be collected and processed. Then the data collected that has also been categorized will be sent to a robot, like now, the one we have right here. And based on the data that the robot is receiving, it should have a certain reaction that will communicate the emotion that the individual felt when reacting to the stimuli, thus creating like a feedback loop. In order to work with our code, we worked with two data sets. The first one was a pre-existing data set that we retrieved from a database called GAIN-EMO, which consisted of raw EEG data from the collected from the EEG device Emotive Epoch Plus. It had about 28 participants with 4 sessions each, and it had 14 channels. Our second data set that we had was one we generated. It was significantly smaller considering the time constraints. So we had 1 participant and we had 3 sessions where we provided them with a visual stimuli, one with a content that they would find boring, something that's a snippet of a horror movie, and finally a bunch of comedy clips. We used the unicorn hybrid black to collect our data set. However, it has been adjusted as we've moved a couple of nodes more towards the front, so we can gather data from the frontal nodes, as those tend to overlap with the Emotive Epoch, but stronger in the unicorn hybrid black. It's stronger, yes. In order to interpret the data set and work with our code, we worked on, as you can see in figure 1, we worked with the survey that was provided along with the data set on how individuals responded to the stimuli. Oh? So to answer your question, when we first trained our CNN model with our pre-existing data set, we noticed a relatively high accuracy, and we worked with, as you can see in a smaller table down here, sadly, we had 14 columns and about 1,024 rows that were collected over 8 seconds, as that's the how Emotive Epoch Plus works. And this is the rough summary of our CNN. It was great. And then we proceeded to use our generated data to fine-tune that model using transference. Based on that, the output of the model resulted in a numerical value, 1, 2, or 3. That numerical value was then sent to now, which it translated and provided with a reaction. The number 1 correlated to the emotion of bored or just neutral feelings. Second was for happiness and excitement, and third was for disgust and fear. The reactions, which we hope to demonstrate soon, is a combination of a change in eye color, the dialogue, voice pitch, as well as movement animation. The first one to the left, I hope, the one with the blue border, is the reaction for when now receives a bored signal. The one in the middle is the excitement stimuli, and the final one is of disgust and fear. We have the unicorn set up on my lovely teammate, and we are going to try to have now react live. So I'm going to ask you to close your eyes and, oh yeah, could you connect it, please? Yeah. Yeah. I'm gonna ask Kasia here to close her eyes.
My internet address is 169,
Thank you.
254,
Okay.
85, 120.
So now people
Great.
from Zurich can control.
Yeah, now you can control now too. And Kasia is going to close her eyes and think of an emotional memory, and hopefully we should be able to translate this with relative accuracy. Might take a bit.
Which one are we making them do?
Kasia, could you think of a happy memory, please? Thank you. Oh.
Okay, in the meantime that we're waiting for that,
Yeah.
I just want to speak about how we have connected all that.
Oh, yeah.
And we have used, basically we have used, here we are, example, perfect, and I want to run it. So we have used a convolutional neural network and based on Keras. Basically we have these sliding windows. We have our matrix of 8 channel and 1024 rows, and we are sliding this convolutional neural network, this convolutional layer, through all these matrix. So now we are selecting the channel and we are building in real time the matrices. For example, here we have the first matrices built that you cannot see, 2024, 8. And here is the emotion. And in a bit, there should work. And if it's not working, that's one of the risks of doing the things in 24 hours. But we must say that we're amazed. Okay. Okay, finally. Okay, try another one.
Yeah. Could we try a neutral emotion? Something boring you could think of? Not sure if the camera picked it up, but for now just had a positive reaction where the ice turned a pink color, now said the word hurrah and did a little jig.
I am so bored.
Yeah. Once
I
again.
am so bored.
Yep.
I am so bored.
Okay.
So basically, we see this as a possible solution for example, having people that with locked-in syndrome, and we think that is really important, for example, for their familiar, the relatives, to have a possibility to interact another time with these people. So we start this project trying to make something useful and not just something funny. And but at the end, it was both useful and funny.
Yeah, it was a very stressful 24 hours, but I think we did manage to get something we're proud of.
Exactly. This is
yeah. These are just 3 moments that truly captured our experience.
This was when the accuracy was 80%.
Yeah, that's Julia doing a little dance.
Perfect.
Thank you very much.